Well, I don't know what happened to the last one. Hopefully it got somewhere. If not, well, I'll have to figure out what I'm going to do. This is number 42. Just in case the last one was lost, we are doing page 300, numbers 33 through 61, odds, simplifying complex number expressions. We want to show all our work. We're simplifying number 42. We have 2 plus I times the square root of 3 divided by 2 minus I times the square root of 3, equaling itself. But now I'm multiplying top and bottom by 2 plus I squared of 3 over 2 plus I squared of 3. The only thing different about this problem and the others that we've done is they've used the commutative property here and put the factor I in front of square root of 3, but it's the same thing as square root of 3I. But I went ahead and worked with it in the present form. Notice doing this number, this bottom, is the conjugate of the original denominator. Those are conjugates. So we're able to use the fact that a plus bi times a minus bi is equal to a squared plus b squared. A in this case is 2. B in this case is square root of 3. So we have 2 squared plus square root of 3 squared. The numerator. Notice we have the same number times itself, so that's just the square of that number. The bottom, of course, is 2 squared, which is 4, plus square root of 3 squared, which is 3. In the top, I'm going to use that mnemonic square double product square. So I've squared 2. The double is this first 2. The product is 2 times I square root of 3, right here, that's the product. And then square, which is we square the last thing. 2 squared is 4. Here at the end, I squared is negative 1. I squared is negative 1. Square root of 3 squared is 3. So the square of I squared of 3 is negative 3. And there it is, right here, minus 3. And then 2 times 2 is 4. And then by the commutative property, I'll do 4 times square root of 3 and then times I. There it is, 4 square root of 3I. And the denominator is 4 plus 3, which is 7. 4 minus 3 is 1. So that gives me 1/7. And then I put 4 square root of 3/7 I right there. Okay? This time I'm just going to go ahead and erase and continue to run because I'm afraid I might have lost the last problem. So bear with me. This is a little bit boring, but this way we won't lose the video. I was hoping that I could just, stop it and pick it back up, but I don't think doing a direct video from YouTube, my web channel or YouTube channel will let me do that. I think as soon as I stop it, it goes ready for upload. So let's continue. Let's do one more type, then I'll attempt to upload this video. The next batch of problems say find the multiplicative inverse of each number. Find the multiplicative inverse of each number. Number 50, I have 2i over 5 minus I. 2i over 5 minus I. And the problem says I want the multiplicative inverse. Multiplicative inverse is what we call a value that when we multiply it by the number that it's the multiplicative inverse of, we get 1. In other words, A inverse is the multiplicative inverse, I'll call it MI, such that it times the original number gives me identity 1. So that means there must be some number, we'll call it, say, x. And we want to find x so that 2i over 5 minus I times x is equal to 1. Well, to do that, it seems like this would be true. So it looks like if we just form a reciprocal like we normally do for numbers, that multiplying this number by its reciprocal should undo it. But since the product should give me 1, then I must do this new number on both sides. And so over here, we see that when we simplify this, this should be the multiplicative inverse of the original number. It's a lot of explanation. Hopefully we see the cancellation here. X is that number that when we multiply the given number, we should get the identity 1. Here we have 5 minus I over 2I. That is not the form we wanted in. We wanted in that A plus BI form. So we're going to multiply top and bottom by the conjugate of 2I, which is the conjugate of 0 plus 2I, which would be 0 minus 2I, top and bottom, which is just negative 2I. The bottom, A is 0, 0 plus 2I is 2I, and 0 minus 2I is minus 2I. So we'd have 0 squared plus 2 squared for our bottom, A squared plus B squared. The top, we distribute negative 2I, and I'll go ahead and do negative 2I times negative I first, and that'll give me positive 2I squared. I squared is negative 1. So positive 2I squared is negative 2. And then negative 2I times 5, that'd be negative 10I. To end it, 2 squared is 4. Negative 2 fourths is negative 1/2. Then we have negative 10 fourths, which reduces to negative 5/2 I. So that should be our multiplicative inverse. Could we check it? I suggest we do. Let's come over here. We shall take original number 2I over 5 minus I. We'll multiply this number, and we'll do it in the form where the numerators are combined and we have a single denominator. So the numerator, negative 1 minus 5I, negative 1 minus 5I over 2. So here we're checking to see if these two numbers are in fact reciprocals. So for the top, 2I times negative 5I is negative 10I squared. Negative 1 times I is negative I. The bottom, 2 times 5 is 10. 2 times negative I is negative 2I. I made a little mistake up here. Negative 1 times 2I is negative 2I. Equals, I squared is negative 1. Negative 1 times negative 10 is 10. And lo and behold, we have a number whose numerator equals its denominator, and that's 1. So that's how we do the last batch of problems. That will take you all the way almost to number 61 through number 55. You will be finding the inverse of complex numbers, and then from 57 to 61 odds, you're back to doing the same kind of thing we did with the first problem. All right, that's been about a 10-minute session. Let's see if it'll upload. See you in Zoom.